section 8.3 cubic one. Cubic one, so we will connect all the data points by cubic curves or cubic span. So for the cubic span, just assume now we have the three data: x I minus 1, y I minus 1, x I, y I, x I plus 1, y I plus 1. So it's 3 points. So before the xi, so this means from xi minus 1 to xi. For this curve in this section, so we use this formula. So yx equals a I minus 1 plus b I minus 1 times x minus x I minus 1 plus c I minus 1 times x minus 1 square plus d I minus 1 times x minus x I minus 1 cube. So you can see for this one, the power to the 3. Okay, power to the 3. A I minus 1, B I minus 1, C I minus 1, and D minus 1 are coefficients of the fitted cubic polynomial between x I minus 1 and x I. Similarly, between the xi and the xi plus 1 in this section, we have another formula. So xyx equals ai plus bi x minus xi plus ci times xi x minus xi square plus di times x minus xi cube. So for equation 3 and equation 4, we need the continuous at this point, also at xi. No matter in the xi, also continuous at the first order derivative and second order derivative. So we can get these 3 equations. Okay. So yxi and the equation 3 equals yxi and equation 4. So this is 3, this is 4. Also, first order derivative at xi also equal. Then second order derivative also equal at xi. So equation 3, equation 4. Then solve this linear equation, so we can get the order coefficients. So a I minus 1, b I minus 1, c minus 1, d I minus 1, and also ai, bi, ci. In MATLAB, so we use this function. So integral 1. For this function, so y equals integral 1 x y capital X capital Y small x minus 1. So a capital X and capital Y are original data. X is the reference. Okay, reference point from the capital X. Then Y, this is the result from our define method. So when we define define method, so this is for the proven one. Okay, so now we go to the method. This is the same, the data point we use the polynomial method in the section 8.2. But now we use these two methods, linear and cubic. Okay, so now this one, so clear all, close all, COC. The file is this one, so example underscore underscore. This is the original data x1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. First one, we need to get the reference data x1. So this is x2. So x2 equals linear space minimum x, maximum x, 1, 0, 1, 101. So minimum x, maximum starting point, then equals length x2, then we need to create y vector according to the x2, the same stuff. So y1 equals 0, n, comma 1, y2 equals 0, n, comma 1. Yeah. So y1, y2 have the same length of the 2. Then just code this function. So y1 equals integral 1 x, y, original date, x2, reference date, linear. So this just is linear method. y2 equals integral 1 x, y, x2 is the same, then we use different method. So then plot x2, y1, just remember this is the linear. The K color is black. Line with 1, hold on, keep this curve, plot x2, y2, cubic y, B for blue, line B 1. Plot xy, O, so this is the circle, color R, red, mark, base color R, also for red, the mark size. So this is solid circle for original data. With on x label x font size 16, y label y font size 16, axis. So this is just fix the range of the x and y. So axis minus 10, positive 10. So this is x minimum, x maximum. The minus 15 translate y minimum 500 y maximum. Then title cubic font size 16, size DCA font size 40, 2004. Then HH equals length. Linear, the first one, y, I2, date, circle, right circle, location, south. That HH, color, not. Okay, so run this one. Okay, so just remember black is the linear. So you can see linear just connect points by linear straight linear. This is very simple. Then the y, so now use the sphere of cubic curve. Cubic y connect all the data into mean here. So you can see this is a cubic curve, cubic span. Just remember cubic span, so continue x and also continuous and first order derivative and second order derivative. This is the length. So you can see, so color, so this means no color is not, no background, no background. This is the sources for a figure, so we know Top is the north, bottom is the south, right? Left is west, right? The southeast is in the right lower corner, lower bottom left, right bottom corner. Okay, so this is this one. Go to okay, so you can see X, so it's X2. So now you have the 101 space between these points equal. So you can see minus 10, minus 9.8, minus 9.2. So that number is 0.2. So minus 10 to 5. The last one is the output. Okay, so this is the cubic file. So before this is bottom we go to have the integral one. Okay, so for the method, so x v this is original data. Then x2 is the reference data of the original method. Here there are a lot of methods. So we use the spline, linear, so just connect points. So this is all the method. So we use this one, but cubic. So you can see for continuous until the C square. Okay, so this is for example. Okay, then for the homework. So this is the same data we use for silicon cycle. This is also is for the forward bias. Then the same voltage in vertical, current in horizontal. No, sorry, vertical voltage in horizontal, current. Here we need to use three methods. Linear, cubic spline, so we can use the function, the interval, inter py function like that. Then fourth degree polynomial method. So this one is from the last section 8.2. You can just copy the code from the last homework. Then, so totally you are the figure, so you need to have the linear fitting, cubic spline fitting, and the fourth degree polynomial fitting, and also original data. Okay, so this is the section 8.2 cubic